IB plus IC. But IC can be given by beta into A. Now, you substitute this value into the above equation. The value of IE can be represented by IE is equal to IB plus beta into IB. What I have done is I have replaced this IC by beta into I. So in this manner, value of IE can be represented. Take IB common over here and 1 plus beta. Thus, you can make one more conclusion that the value of emitter current IE can be represented by IE is equal to one plus beta into IB. So this is one more equation which you can form by using the mathematical relation between the given terms. Now, what we have to do is we have to proceed further by taking a setup and writing down the equations for we have to write down the equations over there for a given circuit. So let us draw a circuit for a transistor where you will be able to see certain parameters. So let us draw a circuit. So now let us understand what things have been done. So this voltage which is applied over here, this battery is VBB. I hope you can see the battery which has been passed. Now what you can observe there that this battery is made variable so that you can make the changes into the voltage applied. Then the resistor which is connected near base terminal is given or denoted by base resistor RB as shown in figure. So that is your base resistor RB. Now the resistor connected into the collector is denoted by symbol RC as shown in figure. So these are current limiting resistors which are used at base and collector. They may have some different function, but let us basically term them as current limiting resistor for this movement. Then the right hand side battery, what you can see over there, this is also a variable battery. This is denoted by VCC. So now let us start with the currents that will flow through the circuit. बच्चों मेरी बात का अभी थोड़ा ध्यान देना मैं क्या बोल रहा हूँ. So the current that flows at this base terminal. So NPN transistor. So this current at base terminal will enter inside the circuit. So the current that flows at this base terminal, which will enter inside this, is denoted by base current IB. So IB is the base current that will enter at this collector at this base region. Then the current that will flow inside the collector terminal can be given by collector current IC. IC is the current which will flow inside the collector terminal. And the current that will come out of the emitter is denoted by IE. So IE is the current that will come out of this emitter. Students, now you can see at this particular location, you can see that the symbol of the NPN transistor, why it is shown like this. Why the symbol of NPN transistor is shown like this, that you can see over here. Because you can see the current is coming out of the emitter. So now The next is to show the voltages. So the voltage between base and emitter is indicated by voltage VBE. This is the voltage between base and emitter by assuming base positive and emitter negative. Now always remember, when you write down VBE, you are terming base as positive and emitter as negative. If you write down VEB, you are terming emitter as positive and base as negative. So जैसे कि आपको मालूम है VAB हम लिखते हैं तो A पॉजिटिव B नेगेटिव कंसिडर होता है और BBA लिखते हैं तो B पॉजिटिव A नेगेटिव कंसिडर होता है. Similarly over here, this voltage between collector and emitter can be denoted by symbol VCE, and this is the voltage taken between collector and emitter, with collector as positive and emitter as negative. See how I am going to write down the equation. From this point to this point, I hope you are understanding. Then I will move like this up to the base terminal. Then once again I will come down. So this is how I will close the loop. So let us start the equation. Let us start down the equation. From this circuit, this it will be like this, plus VBB. You can see there. Then this line minus IB into RB. This is the line which has been drawn. Minus IB into RB. In this segment, minus BBE is equal to 0. Minus VBE is equal to 0. So what you have done, you have completed this loop like this. You have completed this loop as shown in figure, shown by this. So this is equation which has been written towards the base side. So sir, what we are going to do with the equation? Nothing. We are going to find value of this. What we are going to do? We are going to find value of our base current by using this formula. So let us see how to find out value of this base. So nothing, you take this IB into the right hand side and remaining on left hand side. So what you get is value of IB can be given as, see, you will get something like this. Rearranging the equation, I can write down IB into RB can be given by BPP minus VBE. So value of IB can be represented by the following equation. I can write down by using this. I can write down value of IB can be represented by IB equals to EEB minus PPE upon R. So this is how you will be able to write down the value of IB. Now next equation where you have to write down, next equation has to be written down at the emitter circuit. So how I will write down, first I will show you the direction in which the equation will be written. So I will start from this point. First I will cover this line like this. Okay. Then I will move like this. As shown in figure, I will move like this. Then this will be terminate over. So this is how the equation will be written. So let us quickly start writing down the equation. So first line as shown over here, this will become plus Vs. You can see there from negative to positive. So this will become plus Vs. Next, minus IC into RC. Here you can see minus IC into RC. Then minus VCE is equal to, so we have found the equation for the outside also. We can write down the equation and the, so VCC minus output side equation VCC minus IC into RC minus VCE is equal to 0. Before you deal with this equation, you will need to calculate the value of IC. So it can be given that value of IC is equal to ta into height. So this will help you calculating value of IC. Now you can start once again working with this particular equation. So this equation can be given by VCE is equal to VCC minus IC into R. I will directly write down the equation so that we can use it for our further problems. So the above equation can be represented by VCE can be given as VCE is equal to VCC minus IC into RC. So now if you see all these things combinedly, then you will need to know one thing regarding to this topic. That whenever the circuit like this is given, then the first point, assuming all the components values are given, you need to first find out the value of IB, then value of IC, and then value of VCE. So we have just do one small exercise over here. So let me see whether you understand it or not. So there are two conditions that you have to check for this. Let us see the above equation. Let us see the above equation. So first, if IC is equal to 0, so this condition will appear into the circuit when the value of IB is equal to 0. एंड व्हेन द वैल्यू ऑफ आईबी का वैल्यू 0 कब रहेगा, ये इधर हम देख रहे हैं, जब ये आपके वीबीबी का वैल्यू 0 रहेगा ना, तो ये आपके आईबी का वैल्यू 0 रहे. तो वो अभी मैंने वीबीबी का वैल्यू 0 रखा है, ऐसा सम जो बैटरी मैंने वेरिएबल निकाला था, और आईबी का वैल्यू 0 रखा है. सो एट आईबी इज इक्वल टू 0, आईसी इज इक्वल टू 0. नाउ व्हेन आईसी इज इक्वल टू 0, लेट अस डील विद दिस इक्वेशन. ऑल ऑफ अस नो दैट द वैल्यू ऑफ VCE, as you can see there, if IC becomes 0, the value of VCE will become VCC. So this is the first conclusion you need to remember for case number 1 which has been considered. Now let us go to case number 2. The case number 2 is when the value of VCE is equal to 0. Now this value, when it will become VCE is equal to 0, so this is called as saturation. It means that you are putting value of IB into the saturation region. Means whenever value of IB is such that your transistor enters into saturation region, the value of IC VCE will become 0. So now by using above equation, you can see, you can conclude something. You can conclude that if VCE is equal to 0, वो ऊपर वाले इक्वेशन में डालो जो येलो कलर से लिखा है ना, VCE is equal to VCC minus ICRC. So अभी वो VC का वैल्यू 0 कर दिया. So what you can write down? You can write down VC को 0 कर दिया तो क्या हो जाएगा? VCC can be represented as IC into RC. तो अभी आपका IC का वैल्यू क्या हो जाएगा बच्चों? मैं समझा तो रहा हूँ लेकिन आप लोगों के दिमाग में जा रहा है क्या? So how you will be able to represent value of IC? Value of IC can be given by VCC upon RI. This is the maximum value of IC which is possible in a given circuit. So now these 2 points, if you have understood these 2 points, we can represent these points somewhere. So this is how you have found 2 things. So first is known as cut off. मैंने ऊपर लिखा नहीं है लेकिन उसको कट ऑफ बोलते हैं. लिख देता हूँ मैं चाहिए तो. इसको IB को 0 इस सिचुएशन को बोलते हैं कट ऑफ. मतलब ट्रांजिस्टर कट ऑफ रीजन में काम कर रहा है. और नीचे वाले रीजन को बोल दो सैचुरेशन. मतलब मैक्सिमम करंट इज फ्लोइंग थ्रू अ ट्रांजिस्टर. ये इस तरीके से 2 रीजन से आपके ट्रांजिस्टर. तो अभी देखना मैं आपको सामने ग्राफ प्लॉट कर रहा हूँ बच्चों. आई विल प्लॉट अ ग्राफ. So here you are getting a maximum value of IC. We have seen, oh sorry. Here you are getting a maximum value of IC. We have seen what is the formula for that IC. क्या आया था IC का फॉर्मूला याद है क्या? IC is equal to VCC upon RC for the case that we have studied. And this IC is when VC is equal to 0. So you can see here students, ये देखो ये VC का 0 वैल्यू है. जो ओरिजिन है उधर VC का वैल्यू 0 है. तो VC का वैल्यू 0 है ना, उस टाइम पे IC का वैल्यू क्या मिलेगा आपको? VCC अपॉन RC. और अभी IC का वैल्यू 0. IC का वैल्यू 0 मतलब क्या हो गया? एक्स एक्सिस. तो IC का वैल्यू 0 है तो आपको VC का वैल्यू क्या मिलता है? हमने देखा यहाँ पर. VC कैन बी रिप्रेजेंटेड बाय व्हेन IC इज इक्वल टू 0. मैं तो देखा था नीचे क्या आता है VC का वैल्यू? VC इज इक्वल टू VC. सो यहाँ पर मैं लिख सकता हूँ दिस वैल्यू VCE is equal to VCC for this point, the point which has been drawn over here. So in this manner, you will be able to draw a graph between these 2 points, and that is known as a DC load line of a transistor. So when I draw a graph, I just need to plot this line between VCE and VCC, and this line is known as DC load line. क्या बोलते हैं इसको? DC load line. So here you have minimum and maximum points of between VCC and VC. And then what you do is you define your Q point somewhere over here. This is DC load line. The Q point is always defined such that it is at the center of the load line. We take care that the Q point is always at the center of the load line. We try to see that we keep it at the center of the load line. And why it is at the center of the load line? So that the transistor should function for both the cycles, and there are many things behind this, but then you just remember these things for now. This is known as ICQ, that is Q point current, and this is known as VCEQ, that is Q point voltage between collector to emitter, and this is Q point collector current, ICQ. If you want to calculate IBQ, then you can calculate value of IBQ, which is given as IBQ is equal to ICQ divided by beta. Then now I will not write down all the formulas. You can see over here that the basic things regarding to the DC load line has been done. So let us quickly go through what we have seen during this lecture. तो क्या क्या देखा हम लोगों ने उसको थोड़ा सा क्विकली देखेंगे. फर्स्ट वी हैव सीन दिस रिप्रेजेंटेशन ऑफ emitter current in terms of beta. We have seen this mathematical relation IC and IB can be given. IC is equal to beta into IB, IE is equal to IB plus IC. Replace IC by beta into IB, and then you can compute this final equation that IE. Then you can compute this final equation that IE can be represented by 1 plus beta into IB. So this is just one additional mathematical appearance to that. Then we have drawn one circuit in order to draw the DC load line. The same circuit will be also drawn to understand the characteristics of the um, characteristics of the common emitter configuration. You can see over here that first what we have done, we have written the equation like this. I will just zoom it and show it to you. What we have done is we have written the equation for the input loop as shown in figure. So the equation becomes VBB minus IBRB minus VBE is equal to 0. You can see the equation available there. And then what we have done is we have written an equation for the output side. So for output side, we have written equation in this direction. So the equation becomes as shown in figure. The equation becomes VCC minus ICRC minus VCE is equal to 0. After writing down these two equations, what we have done is we have done some mathematical calculations. So now I have my IBK equation as shown over here. I have my IBK equation in my hand, which shows me that my value of IB can be given by VBB minus VBE upon RB. Then this I have got from the input loop equation. From output loop equation, I am going to get this equation VCC minus IC to RC minus VCE is equal to 0. So here I can find out value of VCC. VCE is equal to VCC minus IC into RC. But in order to find out this equation, this relation, I need to first represent value of IC, and I know that value of IC can be given as beta into IB. So by taking this equation now, the equation of VCE, I have obtained two situations. The first situation is known as cutoff situation. So what is the value of IB at the cutoff situation? IB is equal to 0. So when IB is equal to 0, automatically what will happen? Your value of IC will also become 0. So when your value of IC also becomes 0, then what will happen? You put this value of IC into the above equation, that is the equation that you have obtained from the outer loop as shown in this particular section, and you will be able to compute that at cutoff region when IB is equal to 0 and IC is equal to 0, you can find for the given circuit the value of VCE is equal to VCE. Then the next situation is saturation situation. In saturation situation, you put maximum value of IB. When IB is maximum, IC will be also maximum, and when IC is maximum, the value of VCE will become 0. So when value of VCE will become 0, you need to find out what is the maximum value of IB or what is the maximum value of IC. So here you can find that the maximum value of IC is represented by VCC upon RC. So above that, your value of value of IC cannot go. Though you further increase value of IB, the IC will not change. That is called as saturation region. So now what we have done by considering and by understanding these equations over here, we have plotted uh, a graph between VC and IC, and we have plotted their minimum and maximum values over this graph, and we have understood how this functions. And then we have seen one point which is known as Q point, which is generally kept at the center of the load line. What are aspects of this Q point that we will discuss afterwards? But now the values of current and voltages over x-axis and y-axis for this Q point are given. Current is known as ICQ and voltage is known as VCEQ. So this is about today's lecture, students. I will stop the recording now.